Proper use of testers makes it possible to measure voltage, current and resistance value of electrical equipment, detect damage to the equipment quickly and repair it. There are two types of testers, analog and digital. First, let's see how to use an analog tester. When a test lead touches the electrical equipment, the indicating needle moves according to the value of voltage or resistance of the equipment. Using the rotary switch, items to be measured can be selected from among DC voltage, DCV, AC voltage, ACV, resistance value, ohms, and DC current, DCA. A tester is used to locate defects by measuring the voltage of electrical equipment. To measure alternating current voltage, set the rotary switch to ACV. And to measure direct current voltage, set it to DCV. If the voltage range to be measured is not known in advance, set the rotary switch to the highest value in the measurement range. Make zero-level adjustments before measurement. When the red and black test leads touch each other, check if the indicating needle points to 0 volts. If the indicating needle does not point to 0 volts, adjust the needle by rotating the adjustment screws with a screwdriver. Touch the test lead to the terminal of the electrical equipment to be measured. When measuring DCV, touch the red test lead to the plus side and touch the black test lead to the minus side. If the indicating needle moves to the left side of 0 volts, the test leads have been reversed. The test leads should touch their corresponding sides. When the indicating needle moves only slightly, the measurement range is too large to be measured. In this case, make the measurement range smaller and measure again. Conversely, when the indicating needle moves all the way to the right, the measurement range is too small. In this case, the measurement range should be increased before measuring again. Frequently, a weak signal from the sensor is input in a transducer and then converted into an electrical signal of between 4 mA and 20 mA. A tester to verify the operation of the sensor and transducer can be used to measure a weak current, but not a heavy current like the one flowing through a motor. For a heavy current, a clamp meter should be used. Set the rotary switch to DCA. A measurement range of less than 30 mA suffices for measuring the sensor's output current, but when the range of the current is unknown, set the range to maximum. Make zero-level adjustments before starting current measurement. Remove terminals from the circuit and the electrical equipment whose current is to be measured, and touch the test leads in such a way that the tester is serially connected to the terminal. Approach this activity with care, because it only takes a fraction of a second to damage the tester if the test leads are allowed to touch parallel to the circuit. In the resistance thermometer, the resistance value changes according to changes in the measured temperature. The resistance value is measured by using a tester to check whether the resistance thermometer is normal or disconnected. Set the rotary switch to measurement of resistance, ohms. When the resistance value to be measured is not known, set the measurement range to minimum. Make zero-level adjustments, as in the case of voltage measurement. If the indicator needle does not point to 0 ohms, adjust the needle to 0 ohms. Failure to do so will result in an incorrect resistance value. Touch the test lead to the terminal of the device to be measured. If the indicating needle moves only slightly, increase the measurement range and then measure again. When the indicating needle moves sharply to the right, reduce the measurement range to get a more accurate measurement. Like the analog tester, the digital tester can also measure voltage, current, and resistance. A certain type of digital tester is capable of measuring AC voltage frequency, temperature, and even capacitance. As such, it is sometimes referred to as a digital multimeter. Items to be measured are selected by the rotary switch, but because in many cases range setting is done automatically, there is no need to set the range. With the digital tester shown here, measurement of voltage and resistance is automatic, but the range setting for current is manual. The test lead contact point differs only when measuring current. The precautions adopted with the analog tester should also be adopted when using a digital tester. For example, the practice of making zero-level adjustments should be followed before starting measurements. Refer to the instruction manual, because methods for making zero-level adjustments vary according to the type of tester. In the digital tester, voltage received at the test lead is converted into a digital signal, and the result is displayed as a numerical value on the display panel. If OL is displayed while measuring resistance value, the resistance of the object being measured is infinite. In other words, either the cable of the wiring or electric bulb is disconnected, or the switch is off. When OL is displayed while measuring voltage, the voltage being measured exceeds the tester's capabilities. Now let's think about how to locate defects with a tester using this circuit diagram. Here, let's assume a condition where the power source lamp does not illuminate, even when the MCCB is turned on. First, let's check the fuse. You can usually determine the state of a glass tube fuse by looking at it. If visual confirmation is not possible or is inconclusive, voltage can be measured at the output side of the fuse. Even if only one fuse is blown, voltage at the output side will be 0. In the event of a blown fuse, make sure to switch the MCCB off before removing the fuse. The resistance value of the fuse is measured by a tester. The fuse should be replaced if this value is infinite. That is, the needle is stationary in the case of an analog tester, and in the case of a digital tester, OL is displayed. In the event that cables connecting the terminal board with the white power source lamp have become disconnected, then while the MCCB is switched on, measure the voltage between the terminals of the white lamp. If the measured value is normal, the cables are not disconnected. If it is not normal, the cables may be disconnected. Switch the MCCB off, remove the cabling, and then measure the resistance at both terminals of the cables. If the resistance value is nearly zero, the cables are not disconnected. Conversely, the cables should be replaced if the resistance value is infinite. That is, the needle is stationary in the case of an analog tester, and in the case of a digital tester, OL is displayed. While the MCCB is on, measure voltage between the terminals of the lamp. If the lamp does not illuminate despite voltage being at a normal level, the lamp is damaged. The insulation resistance tester is commonly known as a mega. Electric equipment is made shockproof by covering electric cables with an insulating material like vinyl. However, since both humidity and temperature inside ships tend to be high, insulating materials are liable to deteriorate. The risk of electric shock increases if insulation resistance between the coil inside the motor and the case is reduced. As such, insulation resistance between the motor and the case should be measured at regular intervals. Here, let's see how to measure a motor's insulation resistance using a mega. Before measuring the insulation resistance, turn the MCCB off. Unless the motor is dismantled, the coil will not be visible. However, insulation resistance can be measured at the MC output terminal because the motor coil is electrically connected to the MC. So, use the mega's plus side test lead, red, to touch the MC output terminal. Use the other lead, black, to touch the ship's hull or the terminal to which the motor's ground wire is connected. Since many high-precision semiconductor instruments operate using low voltage of between 5 volts and 12 volts, they will break down if subjected to excessively high voltage. Damage usually occurs internally, making it difficult to determine from appearance alone that the semiconductor has been harmed. A mega measures insulation resistance by generating high voltage in the test lead. If a mega is used with a circuit board incorporating semiconductors, the semiconductors may be rendered unusable. Never use a mega for circuit boards incorporating semiconductors. It is possible to use a clamp meter to measure a heavy current like the one passing through the motor. Current flowing through the cables can be measured by a clamp meter without having to touch the cables. This means that current can be measured without having to turn off the equipment being checked. However, the clamp meter cannot accurately measure current flowing through basket-armored cables. Use this type of meter at parts that are free of armor. Now let's confirm the points to remember when measuring current with a clamp meter. Since the tip of the clamp meter incorporates a precision semiconductor component, never attempt to hold any object with the tip of a clamp meter or pull an electric cable with it. While measuring DC current, pay attention to the flow direction of the electric current. An arrow indicating the direction of the current is provided on the tip of the clamp meter. The arrow direction should match the direction of the current. When measuring the current flowing through the motor, note that there are 3 or 4 cables connected to the motor. Attempts to measure the current of all these cables at the same time will yield a value of 0. Measure the cables one by one. Please learn how to use the clamp meter properly to to obtain accurate data.